Okay, so on this one, you're given a sequence of numbers, and we're being asked, well, we're going to find the sum. So you could just add them up, right? Um, these aren't too bad to do. There's like 5 numbers. You can add them up pretty quick. 7 and 13 make 20, plus 10 is 30, and then 4 and 1 make 5, so it's 35. So easy enough to do without, doing a whole formula to do that. But you could certainly run into a situation where you have a lot longer of a list, much bigger numbers, whatever, that having a formula would make it a lot easier. Um, so a finite series is it has an end to it. It just doesn't go on forever. So this would be considered a finite series because there's just 5 numbers in it. Um, and then a finite series can be added up. Um, so basically, they're saying what I was saying, which is this is easy enough to add up, but what if it was a lot longer? You would want an explicit definition that would allow you to do that. All right. So the first step is to find the explicit definition for the sum. Use the commutative property of addition to reverse the order of the terms. And you can substitute the values from the series. So you just took the numbers and flipped them around. Add the 2 expressions for the series, so the original and then the one you flipped around. Um, and what you notice is that each one adds up to the same number. All right. You can simplify it because now you've got 2. If you add up all those numbers, you got 2 of them, right? So you could say it's 5 times 14, but you're going to need to divide it by 2 because you did double it up, right? So you got to divide by 2 to even it out. So then the formula that you can use is n times the first term plus the last term, and then it's all divided by 2, right? Because the first term and the last term are going to give you what that sum number is. And this obviously only works for arithmetic sequences because you need to have a common difference. If this wasn't an arithmetic sequence, this wouldn't work. But um, if you take the first term and the last term, well, that's going to add up to whatever the sum is. Then you can multiply it by how many terms there are, and he's got to divide it by 2 because you're doubling it up essentially. All right, so let's take a look at this formula in action. So what is the sum of the following arithmetic sequence? So if I use the formula we just talked about, you're going to take 2, add it to 22, and you get 24. There's 1, 2, 3, 4, 5, 6 numbers. So you multiply it by 6, and then divide by 2. So essentially, and you're going to multiply it by 3, 24 by 3, and you will get 72. Let's see if I was right. Okay, so using the formula, you take the first term, which is 2, the second term, which is 22, multiply it by 6, which is the number of terms, and you divide it all by 2, and you get 72. Okay. All right, so give it a pause, and then see if your answers match. All right, so for this one, we're just straight up giving you the info you need. The first term is 3, second term is 25. There's 12 terms in the sequence, and we're going to divide all that by 2. I would simplify it. So I just think it's easier just to say, all right, well, that's now 6 times 28. So that's going to end up being, well, 6 times 30 would be 180. To take 12 away, it's going to be 168. Okay. Looking at the other set of numbers, again, you could just add them all up, but let's use the formula that we just learned about. First term is 5. Last term is 41. There are 1, 2, 3, 4, 5, 6, 7 terms. We're going to divide it all by 2. 5 and plus 41 is 46. I would actually divide, if I'm doing this by hand, 46 divided by 2 is 23, so you got 7 times 23. 7 times 20 would be 140, plus 21 would be 161. All right, let's make sure.